Hi everyone, welcome back to the channel and welcome back to Winsome Mathematics. So we have to become fearless and learning is fun. Why? Because replacement is important and this is the introductive slide. So become fearless means what? But we have to learn in a systematic way, we have to learn in a conceptual way. We don't have to plan and we know that the learning is a fun. Okay. So we have to learn in a funny way. Okay. So that each and everything will be convenient and easy to remember. So now introduction is very clear. I hope you all were enjoying. So now coming to the second slide, so that we will discuss that which topic to cover. So simple, we have to see the most awaited topic, that is the proof of gamma 1 by 2, that is equal to root pi. Okay. So beforehand, if you haven't watched all the videos concerning beta and gamma functions, so please check the description. Link is provided and must watch all the videos related to it. Okay, so that you will feel much more convenient in this video. Okay, so now we will cover two methods to prove it. Okay, two methods. You will thinking which one? Simple, nothing. That we have to use whatever we have studied so far. And two methods are very easy and very funny method. Okay, so just watch it. First one is using relation gamma n into gamma n minus 1. I hope you all have remembered this relation that we have discussed it beforehand, and I already told you this is the most important relation. Yes, it is. This is equal to pi upon sine n pi. Very good. Because we have learned that gamma n into gamma n minus 1 is equal to pi upon sine n pi. Okay. And what is the n here? N is this n. Okay. What is used in gamma n? Okay. Gamma function inside gamma function. Okay. So this was our first, this is our first approach, and second approach is using beta mn. Beta mn, now let's think for a while that which definition of beta mn we are going to implement for proving this relation. So you have to think before I am coming to that topic, that point. So first of all, I will cover using the first relation. Okay. So let's think till that when I arrive to second topic. Okay. So now first in first point, what we have to observe that how we will prove it. So this is our concern. So by using this relation, it is very clear that something is here and something is here, and this n is here and this n is here. So our first point is put n equal to 1 by 2. Why is this so? Because when we will put n is equal to 1 by 2, so this will become 1 by 2. Okay, and this will become 1 minus 1 by 2. So 1 minus 1 by 2 is also 1 by 2. So this is gamma 1 by 2 and this is also gamma 1 by 2. Okay, so no any problem. So gamma 1 by 2 and gamma 1 by 2, that means these both are multiplied. That means gamma 1 by 2 whole square. So here we are getting the term which is our target. So simple. So that's why we are using this relation. And now here you will think that but in our approach, it is very clear that we are getting 1 by 2 in LHS and fruitful terms in RHS. What does it mean? Fruitful terms mean that something is very fruitful. That means something is very easy. Like n is equal to 1 by 2. And what is this n? This n is angle of sine. This n is angle of sine. So that we are getting angle of sine and which angle? Pi by 2, and pi by 2 is 1. So just we are getting pi in the RHS and we are getting gamma 1 by 2 whole square. Okay, in LHS. So that's why we have used this relation, and now we can easily write gamma 1 by 2 whole square is equal to pi upon sine pi by 2, and this is equal to pi. So we can easily write gamma 1 by 2 is equal to root pi, because this square is shifted to the root in RHS. Okay, so this is the very easy method to prove it, and no marks will be deducted. So just learn it and just prove it. Okay. So now another method we will observe, that I told you to think. I know you all have thought that which method we have to use and which definition we have to use. Okay. So if it isn't so, so nothing to worry, just we will learn it. Okay. So second, this is very clear by definition of beta and n. by definition of beta mn, and which definition 2 into 0 to pi by 2 sine 2m minus 1 theta and cos 2n minus 1 theta d theta. This definition, why is this so? So I will cover it. Okay. So just watch. 2 into 0 to pi by 2 sine 2m minus 1 theta cos 2n minus 1 theta d theta. So this term is the power and this term is the power of sine and cos. Okay. So our step is very clear that we have to put m and n is equal to 1 by 2. Why is this so? So first of all, approach is again important. So approach in integral we get constant integral. In this integral we are getting constant integral. Why? Because when we will put m is equal to 1 by 2, so 2 into 1 by 2 minus 1. So 2 is cancelled with 2, so 1 minus 1 is equal to 0. So sine raised to power 0 theta. Similarly, cos raised to power 0 theta. So that this is 1, 1 into 1. So inside integral we are getting 0 to, inside integral we are getting 1 only, and here limit is 0 to pi by 2 and 2 is here. So this is our most basic integration. Okay, when we started chapter of integration, we learned that how to integrate to 1. Okay, so we are getting the most fruitful term in RHS and constant integral. And now what is our next step? Our next step is to use relation between beta and gamma, and we have learned that what was the relation between beta and gamma. If you haven't watched, so please watch the proof and watch all the basics of the beta and gamma relation. Okay, so now we are going to use it. So beta mn is equal to what? Yes, gamma n upon gamma m plus n. Very good. So this was our relation, so we will use it. Okay, and we have put m is equal to 1 by 2 and n is equal to 1 by 2. So we will again put it here. So this is equal to gamma 1 by 2. This is also gamma 1 by 2, and this is gamma 1 by 2 plus 1 by 2. So this is 1. Okay, and gamma 1 is equal to 0 factorial, because gamma n is equal to what? N minus 1 factorial. I hope you all have learned it. Okay, so this is 0 factorial and this is 1. So denominator is meaningless. So we are getting what? Here we are getting 2 into 0 to pi by 2. Here we are getting 1 theta, and this is equal to gamma 1 by 2 and gamma 1 by 2. So this is equal to 2 theta 0 to pi by 2, because sorry d theta here. So integration of 1 is theta here, because the uh, limit is in 0 to pi by 2 and variable is theta. Okay, so theta here, and this is equal to gamma 1 by 2 whole square. Very clear. Now what? 2 0 theta, and this is pi by 2. So angle, so this is pi by 2 minus 0. Clear. 2 into pi by 2 is what? Pi. Okay, so this is pi, and this is equal to gamma 1 by 2 whole square. So gamma 1 by 2 is equal to root under I. So true. So again, I will tell you the remaining element of this these both steps. Okay, what was it? So basics is very important. That's why I am discussing. What was it? It was just simple that gamma 1 by 2 whole square in both the process. In the both the process, we have come across gamma 1 by 2 whole square. So in the first process, we substituted n is equal to 1 by 2, so that what? So that here I will see you. Uh, so that here 1 by 2 into 1 minus 1 by 2. Okay, so 1 by 2 whole square. Clear? Similarly, this way also 1 by 2, 1 by 2 whole square, gamma 1 by 2 whole square, and this is equal to. This is the important step. And we focused on it, that how to obtain it. So we have substituted m and n is equal to 1 by 2 here, and uh, in this one we have substituted n is equal to 1 by 2. Clear? So thank you for staying so long. And this was the most important video, because this was the proof of gamma 1 by 2. In the next video, we will see the question sessions. Okay.